Have you ever wanted to predict the future? It sounds like magic, but in the world of machine learning, it is just math. Today, we are going to master the most fundamental algorithm in data science, linear regression. Let's make this simple. Imagine you run an ice cream shop. Over a couple of weeks, you track two things, the temperature outside and your daily sales. If we look at this scatter plot, a clear trend jumps out. As the temperature rises, ice cream sales go up. But how do we turn this visual trend into a mathematical model that can obtain predictions for tomorrow's sales? To do that, we use the equation of a straight line, y equals mx plus b. You might remember this from school, but let's break down what it actually means for our ice cream shop. Here, y is the sales we want to predict. X is our input, which is the temperature. B is the y-intercept, representing our baseline sales. Even if the temperature is 0 degrees, we might still make a baseline amount of money from loyal customers. And M is the slope, which controls how steep the line is. It tells us how much our sales increase for every single degree the temperature goes up. If we change B, the line slides up and down. If we change Ma, the line rotates, becoming steeper or flatter. Our entire goal in linear regression is to find the perfect value for M and B so the line fits our data as closely as possible. But how do we know if a line is the absolute best fit? First, we have to measure how bad our current line is. We draw a vertical line from each real data point to our line. This distance is called a residual, or the error. To calculate it, we just subtract the predicted sales from the actual observed sales. But here is the problem. Some points are above the line, giving us positive errors, and some are below the line, giving us negative errors. If we just add them up, they cancel out, making a terrible line look perfect. To fix this, we square each error. Squaring turns every negative number positive, and it heavily penalizes the line for making really large mistakes. If we take the average of all these squared errors, we get the mean squared error, or MSE. This is our cost function. The higher the MSE, the worse our line is. We want to find the line that makes this error as close to 0 as possible. To minimize this error, we use an optimization algorithm called gradient descent. Imagine the mean squared error is a valley. We start with a random guess for our slope, which puts us high up on the hill. We want to roll down to the lowest point. As we take steps down the curve, we update our slope and intercept. Watch how the line on the left automatically adjusts to align with the dots. At the same time, the error lines shrink. When the ball reaches the very bottom of the valley, we have found our minimum error and our perfect line. Now that we have our optimal line, we can finally do some machine learning predictions. Let's say tomorrow's forecast is 90 degrees Fahrenheit. We plug 90 in as our x. 10.2 times 90 minus our intercept of 465 gives us 453. Looking at the graph, if we trace 90 degrees up to our line and across to the sales axis, it aligns perfectly. We can confidently predict we will make around $453 in sales tomorrow. While linear regression is simple, it is highly interpretable, scales to thousands of variables, and is the actual foundational building block for complex deep neural networks. You have just learned your first machine learning algorithm. Thanks for watching, and see you in the next one.